All right, boys and girls, half-life. Half-life formula is, I want to say it's the easiest formula, but it's not really because the cycles are weird. So the half-life formula is the easiest formula to remember. It's y equals a times the quantity of 0.5 raised to the t power. Now, a couple of things are similar. A is going to stand for the initial amount. Now, with half-life problems, we typically do elements, like scientific elements. So it's going to be how many grams or how much of that element is available, okay? The second part of this formula is the easiest to remember. The rate is always 0.5. It's half-life, meaning 0.5, half of 100. So it's always going to be a decrease of 50%. You're going to need to know this for quizzes and tests, but half-life formula is most representative of an exponential decay problem because it's going downhill, right? The values are going smaller and smaller. In this case, it's going smaller by half every time. Now, T is going to represent something funky here. T represents the amount of cycles the half-life or the element goes through. Amount of cycles. Now, what that means is Titan is chewing a cardboard box. And if he were to chew that cardboard box for another hour, half of it would go away every 10 minutes. That was totally off the cusp. I had no intention of saying that, but he was really chewing that box up. So it's the amount of cycles the half-life goes through. So for example, T is going to represent a fraction that you must simplify before you put it into the calculator. You hear that, right? That's him tearing the box. Can we stop doing that? Can we stop doing that? I'm trying to make a video that was supposed to be like 2 minutes long, but since you want to be Chewy McChorson, okay. It's the total time in the problem, or total amount of time that goes by, total in the problem, total time, sorry, in the problem, like however much time is going by in the problem or how long the problem is going for, divided by the actual half-life of that element. It's like you've never eaten before in your whole life, that you have to eat cardboard. Okay, so let's do a problem, right? So let's say that we have the new element that was just released last night called dramysium. It's super indestructible. It's virtually impossible to get rid of, and it's just like one of the best things ever. Yeah, dramysium. Okay, let's say that I had a 200-gram sample of that element. The half-life of dramysium is 1,000 years. Meaning every 1,000 years that passes, half of it will go away. So just a little off-topic calculation. If I started with 200 grams and 1,000 year passed from right now, how much will be left after 1,000 years? Yes, 100 grams will be left over because half of it's going away every time. Okay. Now, in the context of the problem, I'm not going to make it that easy. I'm going to give you a years. That's a little bit weird. So let's do this. So let's say 200 times the quantity of 0.5. Now, let's say that since the half-life is 1,000 years, let's say I want to know how much is left over after 5,000 years. So here's the deal. 5,000 is going to represent the numerator of my fraction. So 5,000 would go in here, and the half-life, the actual half-life of that element is 1,000 years, which would go in the denominator. So you're going to simplify that fraction, right? So 5 over 1, did I do that right? Yeah, 5 over 1 is going to be 5, meaning the cycles that went through in that problem was 5. So you're going to plug that in the calculator, and you're going to get an answer. Now, you certainly could do this without using the calculator, but it's going to get a little bit crazy after a while. So after 5 cycles, I'm going to be left with 6.25. He's really tearing that apart. Wow, that's pretty impressive, actually. 6.25 grams is what we're left with. Now, it gets a little tricky when I give you a half-life, but the amount of time that goes by in the problem is less than the half-life. So for example, let's continue to use this fraction, right? T equals. Let's say we use the same problem and I say that the half-life of dramysium is 1,000 years. Remember that the actual half-life of the problem or the element is in the denominator. Well, what if I only wanted to see how much was left after 500 years? It's still a fraction, you're still simplifying it, and you're putting, if that's a decimal, you're putting that in the calculation. So this is going to be 200 times the quantity of I can't even keep a straight face, dude. 200 times the quantity of 0.5. Now, 500 divided by 1,000 is 1/2, or 0.5. The half-life is 0.5. Half of a half-life went away, right? So I'm going to use that calculation here, and this is like, he's got a good 2-foot piece of cardboard in his mouth. No, 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 no. What is it? What is it with the cardboard, buddy? I don't get it. I don't get it. Okay. 200 times 0.5. So the 0.5 power is going to be. Now this is where it's weird because I'm usually not. I'm usually not going to ask it around, but for purposes of this video, so so the dog doesn't go crazy, we're going to stop it. So 141. Please stop in there. Stop in there. Ew! I had to really reach in your mouth for that. That's gross. Okay. All right. Yeah. Bye.